Good morning, dear students. In previous class, we have discussed about sampling, basic definition of sampling, and type 1 error, type 2 error, testing of hypothesis, how to test a variety of formulas we have discussed in previous class. Now, let us move to the test of significance of proportions. Now, let us directly start with the problems. We have already done with the basic explanation and all in previous lecture, right? Now a coin is tossed 1000 times and it turns up head 540 times. Now dice on the hypothesis is unbiased. Now here we have to check whether the hypothesis is biased or unbiased. That's it. Okay. Now first, what we have to take here, let us suppose the coin is unbiased. That unbiased means what? So coin having both head and tail. Biased means both side may be head or both side may be tail. But in the case of unbiased, it is the natural coin. Okay. Now let us suppose that the coin is unbiased and P represent probability of getting a head in one toss. Already we have discussed probability of getting a head or tail. It is what? Equal importance, that is 1 by 2, right? Now the probability of getting head in one toss is half. That is P equal to half. So what is Q? Probability of not getting head or probability of getting tail. That is also half, right? If you add, you should get 1. Now, expected number of heads in 1000 toss is how much? What is expected number? Mu. Mu equal to what? NP. Okay. What is NP here? N means number of times. So, 1000 times into P. P is what? Probability of getting head. 1 by 2. So, 1000 into 1 by 2, that is 500. Actually, this is the expected number of heads in 1000 tosses. But what they observed, that is 540 times they have given. So what is the actual number of heads? Actual number of heads, that means they observed 540 times, that is x. So x equal to 540 and our expectation is n into p, mu equal to np. It is mu equal to np. N is nothing but number of times tossed. P is nothing but probability of getting head. So it is 500. So what is x minus np? That is equal to what? 540 minus 500. That is equal to 40, right? Now what is z equal to what? Standard normal variate. What is the formula? X minus mu by sigma, right? That is x minus np by root npq. Right, standard normal variate. But x minus np is nothing but 40 and root npq. NP is what? 500, right? Already we observed NP is 500 into 1 by 2 means 250, right? So what we will get? 40 divided by 250 means 4 by 25. Its answer is 2.53. It does not exceed the limit 2.85. This already we have given in the previous table. Go through with the table once again. So it does not exceed the limit. Therefore, the coin is unbiased. Okay. Now let us move to the next example. Here. Now the result extracts revealed that in a certain school over a period of 5 years 725 students had passed and 615 students had failed. Test the hypothesis that the success and failures are in equal proportions. Now, what is the total number of students? We have to add both passed and failed students, right? 725 plus 615, that is 1340. Now, what is the proportion of success? Observed proportion of success is what? That is nothing but probability of students passed. What is the definition of probability? Possible outcome by total outcome. What is possible outcome? Number of students passed or success 725 divided by total number means 725 by 1340. That is equal to what? 0.54. Now, suppose that the success and failure are in equal proportion. Then what is P and what is Q? P equal to 1 by 2. And what is the difference in proportion? X minus NP, right? We have to find. Here, instead of N, here just we need to take p, x minus p, because here n not given here, right? So 0.54 minus 0.5, that is what? 0.04. Now what is standard deviation of proportion of success? Root npq by n, or here root n, here n can be written as root n into root n. So 1 root n get cancelled, root pq by n, that is nothing but p is 0.5, q also 0.5 divided by n. Here this n is 1340. Now here, or else you can use the previous formula also, or you can use this formula also. We will get 0.014, right? So in terms of proportion, z equal to what? X minus mu by sigma, that is 0.04 divided by 0.014, that is 2.86, but it exceeds the limit 2.58. Thus the hypothesis that the success and failure are equal in proportion is rejected, or it is not in equal in proportion, right? Or you can write it in the direct form of this one, x minus mu by root npq. X is nothing but what? Here observed number of success 725, and mu is nothing but what? Expected number of success, that is here 670. So 725 minus 670 divided by root into n is here total number of students 1340. P is nothing but probability of success half, failure half. Simplify this, you will get 3.005. Again, which is greater than 2.58. Therefore, the hypothesis is rejected. Now, a sample of 900 days was taken in a coastal town, and it was found that on 100 days the weather was very hot. Obtain the probable limit of the percentage of very hot weather. Now this also we have discussed probable error and all formulas given. Now probability of very hot weather, P equal to what? Possible outcome by total outcome, 100 by 900, that is 1 by 9. So P equal to 1 by 9 means Q equal to what? 8 by 9. But what is probable error or probable limits? Formula is P plus or minus 2.58 into root PQ by N. Okay, so what we will get here? P is nothing but 1 by 9. Simplify 0.111 plus or minus 2.58 into root. What is PQ? 1 by 9 into 8 by 9 divided by N. N is nothing but 900. So simplify here, you will get 0.111 plus or minus 0.027. That is 0.111 plus 0.027 and 0.111 minus 0.027. You will get 0.084 and 0.138. So what is probable limit of very hot weather? That is 8.4% or 13.8%. In terms of percentage, you have to calculate, right? Now, in a sample of 500 men, it was found that 60% of them had overweight. What can we infer about the proportion of people having overweight in the population? Again, same formula we have to do, because here proportion asked, right? So probable limits you have to find. What is probability of persons having overweight? So 60 divided by 100. 60% means 60 by 100. That is P equal to 0.6. Obviously Q equal to 1 minus P. That is 1 minus 0.6 is nothing but 0.4. What is probable limit? P plus or minus 2.58 into root PQ by N. So P is nothing but 0.6 and plus or minus 2.58 into root 0.6 into 0.4 divided by 500. Simplify 0.6 plus or minus, if you simplify this part, you will get 0.0565. So that is nothing but 0.6 plus 0.0565 and 0.6 minus 0.0565, that is 0.5435 and 0.6565. So thus the probable limits of people having overweight is how much? 54.35% and 65.65%. In terms of percentage, you have to write. Now once again, a survey was conducted in a slum locality of 2000 families by selecting a sample of size 800. It was revealed that 180 families were illiterates. Find the probable limits of the illiterate families in the population of 2000. So what is probability of illiterate families? You have to check. Out of 800 families, here they have given 180 families are illiterate. So what is P? P equal to 180 by 800, that is 0.225. So what is Q? 1 minus 0.225, that is nothing but 0.775. So what is probable limit of illiterate families? P plus or minus 2.58 into root PQ by N. That is 0.225 plus or minus 2.58 into root what? P is nothing but 0.225 into 0.775 divided by N. N is nothing but how many? Here sample size of N is small n 800. Now simplify this part into 2.58, you will get 0.038. So 0.225 plus or minus 0.038. What we will get? 0.225 plus 0.038, that is and 0.225 minus 0.038, we will get here 0.263 and 0.187 respectively. Now here this is for what? Single family you found. Now we need to find it for 2000 families. Therefore the probable limits of illiterate families in the population of 2000 is 2000 into 0.187 and 2000 into 0.263, that is 374 and 526 are probably illiterate families. Okay. Now, in a hospital, 230 females and 270 males were born in a year. Do these figures confirm the hypothesis that sexes are born in equal proportions? We have to check. Now first we have to find total number of kids or total number of births. So 230 plus 270 means 500 births. Now do these figures confirm the hypothesis that sexes are born in equal proportions? Either you can take boy or you can take girl. It is left to you. Now observed proportion of females is what? 230 female out of 500. So what? 23 by 50, that is 0.46, right? Now, assuming that the sexes are born in equal proportion, that means equal chance of occurrence, boy and girl, that is 1 by 2, 1 by 2. P is 1 by 2, even Q also 1 by 2. So, because of this, proportion of female birth is equal to 1 by 2. That is P equal to 1 by 2. Also Q equal to 1 by 2. So, what is the difference in proportion? P actual proportion is P is 0.5, that is 1 by 2, and whatever we observed here, that is 0.46, right? So the difference obviously, so x minus, here what we have to do? P minus observed. So 0.5 minus 0.46, we will get what? 0.04. So what is standard deviation of proportion of females? Root npq by n or root pq by n. Either you can remember this formula or this formula. So what will get? P equal to half, q equal to half, and n equal to what? 500. Simplify, you will get 0.0224. And what is the difference divided by standard deviation, or x minus np by root sigma? Also you can write same formula. Okay, so what we will get? 0.04 divided by 0.0224. So we will get 1.786. Again it is less than the given limit 2.58. Therefore the given hypothesis we have to accept, that only we have to write. Thus we conclude that the figures are conformal with the hypothesis that the sexes are born in equal proportions, right? Now let us move to the another sum. See here, in 324 throws of a 6-faced die, an odd number turned up 181 times. Is it reasonable to think that the die is an unbiased one? Now first we have to check what is P. In a die, how many phases? 6 phases, right? But how many possibility of odd number turns up? 1, 3, 5. Only 3 possibility. So what is P? P equal to 3 by 6, that is 1 by 2. Since P equal to 3 by 6 or 1 by 2, what is Q? That is 1 minus P, that is again 1 by 2. So what is expected number of success? N into P, right? Expected number means N into P. What is that? N? 324. What is P? 1 by 2. So 324 into 1 by 2, we will get 162. But what they observed? They observed 181. So Observed number of success is 181. Now we have to take the difference. Observed number of success minus expected number of success. That is 181 minus 162. That is what? 19, or x minus np. X is nothing but observed number of success. NP is nothing but expected number of success or mean, right? So what is x minus NP? 19. And what is Z here? Standard normal variate. X minus NP divided by root NPQ. That is 19 by root N is what? 324 into P means 1 by 2 into 1 by 2. Now if you simplify root 81 you will get, but root 81 is nothing but 9. So 19 by 9, that is 2.11. Again it is less than the given limit 2.58. Therefore we can conclude that the given die is unbiased, right? Now a die is thrown 9,000 times and throw of 3 or 4 was observed 3,240 times. Show that the die cannot be regarded as an unbiased one. Now a die is thrown 9,000 times and a throw of 3 or 4 was observed 3,240 times. Show that the die cannot be regarded as an unbiased one. Now here you need to find what is P and what is Q and what is expected number of success. Always you should remember one thing, expected number of success is always nearly equal to the observed number of success. Okay. Now what is given? Observed number of success given. We need to find expected number of X given here. We need to find NP. What is P here? The probability of getting 3 or 4 in a single throw. What is probability of getting 3 or 4 in a single row? Probability of getting 3 is 1 by 6. Similarly, probability of getting 4 in a die is also 1 by 6. So 1 by 6 plus 1 by 6, 2 by 6, that is 1 by 3. Right? So P equal to 1 by 3. So what is Q? 1 minus 1 by 3 or 1 minus P, that is 2 by 3. Therefore, expected number of success is what? N into P. What is N here? 9,000 given. 9,000 into 1 by 3, that is nothing but 3,000. But what is observed success? 3,240 given. So X is 3,240 and NP is 3,000. So what is the difference between them? 3,240 minus 3,000, that is 240 is the difference. Now what is standard normal variate? Z equal to X minus NP by root NPQ. So 240 divided by root N is nothing but 9,000 and P is nothing but 1 by 3, Q is nothing but 2 by 3. Simplify this, you will get 240 by root 2000, that is nothing but 5.37. But this is obviously this is greater than the limit 2.58. So z equal to 5.37, which is greater than 2.58. Therefore, we can conclude that the given hypothesis is not accepted, or we can write it is not a biased one. So unbiased one, that is we have to write it is a biased one, right? Because here they have given show that the die cannot be regarded as unbiased. Cannot be unbiased means it is obviously biased. So the given die is biased because it exceeds the given limit. Now next, a sample of 100 days is taken from meteorological records of a certain district and 10 of them are found to be foggy. What are the probable limits of percentage of foggy days in the district? This one already we have discussed. Probable limits means P plus or minus 2.58 into root PQ by N. This is the formula. This we have discussed already in the previous lecture. What is P? P is nothing but proportion of foggy days in a sample of 100 days. So what is P possible? Out of 100 days, 10 days are foggy days. So 10 by 100 is P. That is nothing but 0.1, right? P equal to 0.1. What is Q? Q is 1 minus P, that is 1 minus 0.1, that is 0.9. So how to find the probable limits? Probable limits of foggy days equal to P plus or minus 2.58 into root PQ by N. That is 0.1 plus or minus 2.58 into root 0.1 into 0.9 divided by 100, or 0.1 plus 0.774, that is nothing but 0.1 plus 0.0774, that is 0.0226, and 0.1 minus 0.0774, that is 0.1774, or in terms of percentage 2.26% and 17.74%. Dear students, please remember, for the probable limits you have to write it in the form of percentage. Okay, thus the percentage of foggy days lies between what? 2.26% and 17.74%. Now, let us discuss one more example. A random sample of 500 apples was taken from a large consignment and 65 were found to be bad. Estimate the proportion of bad apples in the consignment as well as the standard error of the estimate. Also find the percentage of bad apples in the consignment. Now what is meant by P? Proportion of bad apples in the sample. Now what is the bad apple in the sample? Total sample is how much? Total apple 500, but 65 were bad apple. So 65 by 500 gives us what? 0.13. So P equal to 0.13. So how to find Q? Q is nothing but 1 minus P, that is equal to 0.87, right? So what is standard error proportion of bad apples? Just root pq by n, or directly you can write this is probable limit of bad apple equal to what? P plus or minus 2.58 into root pq by n. Directly you can use this. P is known quantity 0.13 plus or minus 2.58 root pq. P is nothing but 0.13, q is nothing but 0.87, and n is nothing but 500 samples. So just apply that. No need to calculate this separately. Just apply that. You will get 0.13 plus or minus 2.58 into, if you simplify this part, 0.015, that is 0.13 plus or minus 0.015 into 2.58 means 0.0387, that is nothing but 0.13 plus 0.0387, that is 0.0913, and 0.13 minus 0.0387, that is 0.1687. So finally what we will get? 9.13% and 16.87%. So thus the required percentage of bad apples in the consignment lies between what? 9.13% and 16.87%, right? Now all problems are similar here. Just you need to remember what is probable limits and what is the standard normal variate Z. The two concepts you have to remember here. Now the mean and standard deviation of the diameters of a sample of 250 rivet heads manufactured by a company are 7.2642 millimeter and 0.0058 millimeter respectively. Find first one 99%, second one 98%, third one 95%, fourth and 90%, fifth and 50% confidence limit for the mean diameter of all the rivet heads manufactured by the company. Now, what and all given quantities you have to write. According to that, you have to find the confidence limit. Again, confidence limit formula we have already discussed. What is x bar here? Mean given what? See, see here, the mean and standard deviation of the diameter of sample of. So, n sample is n equal to 250. Mean is what? Here mean means sample mean, that is x bar. X bar equal to what? 7.2642, and standard deviation is sigma, that is 0.0058, and n is given to 50. Now what is confidence limit for mean is given by what? X bar plus or minus ZC into sigma by root n. What is ZC? ZC is the confidence coefficient. So that we have to check here. Corresponding to the confidence level, we have the following from the normal probability tables. Now what is confidence level? They have given 99%, then 98%, 95%, 90% and 50%, and this ZC is available in the standard normal variated table. Okay, that table they will provide you. From that you can come to, you can observe that 99% is 2.58. Similarly this, like this, all the concept, these two maximum we are using, that is 5% area covered, that means 95% confidence level, that time 1.96 is the ZC part. that is confidence coefficient, and 99% is here 1% level of significance, that is confidence level is 99%. That time ZC is 2.5. This two repeatedly we are using, right? Now with the help of this, just you obtain the simplification part. What is sigma by root n? Sigma is already known, that is 0.0058 divided by root 250, right? That is what we are getting, 0.00037. So what is the confidence limit for various confidence level? This is common definition. See here, 7 x bar is nothing but what, 7.2642 is common, and ZC only varies, and rest all this is also we have done, that is what, 0.0058 by root 250 means we have obtained already, just you need to vary ZC part. So what we will get here, 7 point for 99% you will get what, 7.2642 plus or minus 2.58. This is ZC value already given in table here, right? 2.58, then into this value 0.00037, that is what, 7.2642 plus or minus, just multiply this and write, you will get like this. If you want to simplify, you take plus value separate, then minus value separate. Now similarly for the next, what they given, 98% given. For this ZC is 2.33. So because of that, what we will get here, you have to here 7.2642 plus or minus 2.33 into this value common, even this first value common, right? Only the thing is the change in what, the value of this table we have given, right? 98%, 95%, 90% and 50%. These values will vary, and the first value remains same, x bar, that's 7.2642, and sigma by root n value also remains same, that is what already we have found, 0.00037, right? Now simplify this, you will get this value into this 0.00086. So either you can write a plus addition of this and subtraction of this. Similarly, multiply this and write, you will get here 0.00073, and this plus or minus the value. So sum and difference of this value you have to write. Similarly here, 7.2642 plus or minus, if you multiply you will get 0.00061. Similarly here, 7.2642 plus or minus 0.00025. Now either you can keep as it is, or you can take the sum and difference of these values. Okay. Now an unbiased coin is thrown n times. It is desired that relative frequency of the appearance of heads should lie between 0.49 and 0.51. Find the smallest value of n that will ensure this result with the first one 95% confidence, second one 90% confidence. Now here P stands for what? Probability of getting head, that is 1 by 2. Q stands for not getting head or tail, that is again 1 by 2. What is error here? Proportion of heads, root PQ by n, that is what you will get. PQ is nothing but 1 by 2 into 1 by 2, that is 1 by root 1 by 4 into n, or 1 by 2 into root n. Now first case what they given? Probable limits for 95% confidence limit. So for 95% confidence limit, what is the value? Here P plus or minus 1.96 into root PQ by n. And for 1% confidence limit, probable limit is P plus or minus 2.58 into root PQ by n. Now since here first case is 95% confidence limit, so it will be P plus or minus 1.96 into root PQ by n. Now if you substitute each and every value, you will get 0.51 or 0.49. Now here P value is 0.5, this is 1.96, and root PQ by n is what? 1 by 2 root n. Now which is nothing but what? That is either you will get 0.51 because they have given here, or you will get 0.49. Equate both, so 0.5 plus 1.96 by 2 root n is equal to 0.51, and 0.5 minus this value is lies between they have given, which is equal to 0.49. Now find the value of n in both the case here. So what you will get here? So simplify 0.51 minus 0.5 means 0.01. So 1.96 by 2 root n equal to 0.01. So what is n value? So 1.96 divided by 2 into 0.01 is root n. So what is n? Similarly here 0.5 minus 0.49 equal to 1.96 by 2 root n, or 2 root n is nothing but what? 0.5 minus 0.49, 1.96 divided by this value you will get. So simplify this. So root n equal to 1.96 divided by 0.02, that is 98. Now again if you simplify n, you will get this value only. Okay. Finally we have to find the value of what? N. Now an unbiased coin is thrown n times. It is okay. This is the same problem we have done already. Now next what they given, take the confidence coefficient equal to 1.645 for 90%. That also we have discussed already. For 95%, 90% what is the value? 1.645. See from this table. Okay, from this table what we will get here? Again use the same concept, p plus or minus what? 1.645 into root pq by n. Simplify this, you will get 1.645 by 2 root n equal to 0.01, or root n equal to 1.645 by 2 into 0.01, that is 0.02. Simplify, you will get 82.25, or n equal to what? 6765 value. Okay, now here you need to obtain the confidence limit as well as z value, standard normal, variate expression, and solve the problems.